everyone, welcome back to Deeksha Karnataka YouTube channel. I know many of you have requested this video and we are here with this video, most important numericals for your PU2 midterm. I am going to cover all the chapters that is there in your midterm syllabus. Also, you can skip based on your level of preparation. I will mention that which chapters you can skip, which chapters you can have as a backup. So that's why this is a very important video, and don't go anywhere. If you have not yet subscribed to our channel, don't forget to subscribe. The link is subscription button is given in the below. Also join our WhatsApp channel. You will get this PDF available in our WhatsApp channel. So don't forget to join our WhatsApp channel. The Google Drive link will be shared exclusively in our WhatsApp channel only. Now, let's start with your question paper pattern. So, 4 numerical questions will be given. Out of the 4 numerical questions, you have to answer any 2 of them. Total marks given here as 10. Also, I will be covering some 2 or 3 mark question, but not all. There is a 2 mark numerical and 3 mark numerical is also there. So, total 15 marks of numericals. You can skip those 2 and 3 mark numericals if you are not confident, if you are not sure how to solve them, because that is completely optional. In this 4 questions, there is no option. You have to solve 2 out of 4 questions. Now, let's see what are the chapters that I am going to cover. Electric charges and field, electric potential and capacitance, current electricity, alternating current and ray optics. Now, out of all these chapters, electric charges and field and electric potential and capacitance, from here you are expected to get at least 1 numerical questions. It is guaranteed you will get 1 question. In your midterm, perhaps you will get one question from each of them, but you cannot expect that. At least 1 numerical question will come from these 2 chapters. Now, remaining 4, 1 from current electricity, 1 from alternating current and 1 from ray optics. So, total 4 questions you have to answer. Out of the 4 questions will be given, and out of the 4 questions you will have to answer any 2 of them. Clear? Now, before I start, I generally recommend solve numericals from these 2 first chapters. These are easy chapters. If you just understand few formulas and how to apply them, questions are also almost patterned. So, same pattern question repeats every year. So, that's why these 2 chapters I recommend strongly. Second chapter that I recommend is alternating current. Again, if you are allowed to use small calculators, obviously it is allowed in your physics exam. Not the scientific one, but the simple 1, 2, 3, 4, 5, 6, 7, 8, 9 one calculator is allowed. So, you have to use calculator to solve these chapter questions, but otherwise this is very straightforward. Just put the formula, use the calculator properly and calculate it. So, that's why alternating current is my second suggestion. Thirdly, ray optics can be your backup. Now, current electricity, generally sometimes you will get a straightforward question from current electricity that can be solved using a formula. So, in that case you can attempt current electricity as well. Otherwise, if it is a circuit based questions, I have seen students making mistakes while solving questions which are basically circuit based question. So, generally try to avoid current electricity if you have not practiced too much of circuit theory based question, and it will be a very long tedious process. I will be solving some circuit theory questions in future, but for your midterm, because your midterm is very soon, so I am not going to cover circuit theory based question in current electricity chapter. I will be covering general other questions from current electricity. If those type of questions coming, then definitely you can try and solve them out. Now, let's start with the first chapter, electric charges and field. Consider a uniform electric field E equals to 3 into 10 to the power of 3 I cap NC. So, what is the meaning of this I cap? It means that the electric field exists only in the x direction. So, electric field exists only in the x direction, because unit vector in the x direction is x cap, I cap, unit vector in the y direction is j cap, unit vector in the z direction is k cap, 3-dimensional plane. What is the flux of this electric field through a square of 10 centimeter on a side whose plane is parallel to the YZ plane? Now, what is a YZ plane? So, very important to understand that YZ plane is basically is a plane which is actually like this. It is a three-dimensional plane. So you have to understand it is a three-dimensional plane, not like simple two-dimension. So it will be like this. Okay. So this is a YZ plane. Okay. Now the area vector of this plane is again in the same direction as the x-axis. So area vector and E vector both are in the same direction. So angle between them is 0 degree. So angle between them is 0 degree. So what is electric flux? Electric flux is given by E dot A or EA cos theta. It is a scalar quantity. Okay, electric flux is a scalar quantity. So E value is given. Okay, area you have to calculate. Area is given as 10 centimeter square. 10 centimeter square means a square having each side 10 centimeter. Okay, so area of each side of 10 centimeter. So that means area is basically 10 centimeter into 10 centimeter. Be careful, it is not as 10 square centimeter, it is 10 centimeter each side. That means area has to be multiplied 10 by 10. Now as I said, you have to convert it into meters, 10 to the power of minus 2 into 10 into 10 to the power of minus 2. Each centimeter has to be converted meter square. So it will be 100 into 10 to the power of minus 4 meter square, or 10 to the power of minus 2 meter square. So this is the area of the surface. Now you have to just put this same value in this equation. This calculation is compulsory, by the way, you have to show this calculation. Now put that value in this equation. So E is given. You don't need to use I cap, J cap, don't get confused. I cap is in the x direction, your area vector is also in the x direction. So don't get confused, both are basically, only thing that you need to consider is that theta is 0, cos 0 is 1. So you can directly use this value as it is. So 3 into 10 to the power of 3. More complicated question does not come for your PU board. You might face more complicated questions for your JEE exam, not for PU board exam. Okay. So area we have calculated 10 to the power of minus 2. So just put the value and you will get 3 into 10 to the power of minus 1. 10 to the power plus 1. Okay. Minus 10 to the power of 3 into 10 to the power of minus 2. So 10 to the power of plus 1, that is simple 10, that is equals to 30. Now unit is very, very important, Newton per coulomb into meter square. Newton per coulomb into meter square, that is 30 Newton meter square per coulomb. Okay, so this is the unit. So this is the electric flux through this particular surface. What is the flux through the same square if the normal to its plane makes an angle 60 degree with the x-axis? So same question, same problem, only thing that you have to consider is that now cos theta is not 1, in this case cos 0 was 1, so cos theta was 1. Now you have to calculate the same electric flux if the theta is not 0 but 60 degree, that's it. So you can use the same value EA cos theta. Now here we are solving for theta equals to 60 degree. Here theta was 0 degree. Okay. Now E into A we have already calculated. Okay, if you don't understand, you can put the value again and calculate. Otherwise, E into A we have already calculated. So we will use the same value 30. Now what is cos 60? That is very, very important. Cos 60's value is half. So 30 into half, that is 15, and unit will be same, Newton meter square per coulomb. Okay, you don't need to mention unit in each and every step, but the final answer should always have a unit. Okay, let's check the answer once. So 30 Newton per meter square, 30 Newton meter square per coulomb and 15 Newton meter square per coulomb is the answer. Easy question. So let's move on to the next question. 2-point charges QA equals to 5 microcoulomb and QB equals to minus 5 microcoulomb are located at A and B separated by 20 centimeter in vacuum. So now you can see these two charges are like dipole, okay, but because the distance is quite high, 20 centimeter is high. If it is millimeter or micrometer, you can still consider them to be a dipole, but 20 centimeter is very long distance. You can even measure it using your scale. That's why this is not a dipole. So don't get confused with this. So we have two charges, and remember, whenever you are solving a numerical question, this is a very pro tip. Whenever you are solving a numerical question, try to draw the diagram, not always necessary for scoring marks, but for understanding the question. Step number 1, okay. So whenever you are solving a question, try to draw a diagram to understand the question by yourself. That is very, very essential. Secondly, try to put the equations properly, okay, try to minimize the calculation as much as possible, and at the last step of your calculation, use the calculator if required. Okay, otherwise don't use the calculator each and every step except alternating current. In there you have to use calculators in each and every step. Otherwise, in normal cases, try to avoid calculator as much as possible. Use the calculator at the last step of the question. So here we have QA equals to 5 microcoulomb, okay, and here we have another charge which is minus 5 microcoulomb. Okay. So 5 microcoulomb and minus 5 microcoulomb, the distance between them is given as 20 centimeter. Okay. What is the electric field at the midpoint O of the line joining the charges? So what is the electric field at the midpoint? Suppose this is the midpoint, say O. We are trying to find electric field at this point O. Okay. Now how to calculate that? For that, what we have to use? We have to use a simple concept that electric field is basically, so electric field due to positive charge is always away from the charge. Electric field due to positive charge is always away from the charge, and electric field due to negative charge is always towards the charge. Okay. So electric field due to positive, this is a positive charge, so electric field due to this positive charge is away from, this is a negative charge, so electric field due to the negative charge is always towards the charge, right. So be careful, and you have to understand this problem. If you understand this simple concept, then any similar questions you will be able to solve. Okay. So in this case, both plus and minus electric fields are in the same direction. And not only that, because the charges are of same magnitude, they will also have the same magnitude as well. If you see the midpoint, midpoint means this distance is 10 centimeter, this distance is also 10 centimeter. So same distance and same magnitude, so electric field's magnitude will also be same. So we can write that E plus equals to E minus equals to E in brackets say, okay, magnitude wise it will be same. So E is basically KQ by R square, as simple as that. So what is the net electric field? Net electric field is basically E plus E minus, right? Both are in the same direction. So always consider the direction. Don't put the sign of the charge in this equation. Don't put the sign of the charge in this equation. You consider the direction. Based on the direction, you have to find whether they are getting added or subtracted. If some cases you will find E plus, suppose both are positive, one is in this direction, another one in the opposite direction. So in that case, you have to subtract. Okay. In this case, both are in the same direction and magnitudes are also same. So we can write this as E plus E, that is equals to 2E. Okay, so this is the net electric field, that is what we are trying to find. So now 2 into what is net electric field? K Q by R square. Now what is value of K? K is easy, 9 into 10 to the power of 9. What is the charge? Charge is 5 microcoulomb, so 5 into 10 to the power of minus 6 divided by R square. What is R? R here is not 20 but 10 centimeter. So 10 centimeter means 10 into 10 to the power of minus 2 whole square. okay, 10 into 10 to the power of minus 2 whole square. Now simplify this, you will get, so if you see 2 into 5 is 10, 10 into 9 is 90, okay, into, so if you see 10 to the power of 9, 10 to the power of minus 6, so it will be 10 to the power of 3 divided by 10 into 10 to the power of minus 2, that means 10 to the power of minus 1 whole square. So it is 10 to the power of minus 1 whole square. So what will be the value? 90 into 10 to the power of 3 divided by 10 to the power of minus 2. So that means E net equals to 9 into 10 to the power of 4. I have taken this 0. So 9 into 10 to the power of 4 and plus 2 once you take this in the numerator, right. So if you take this from denominator to numerator, the 10 to the power minus value will become plus. So 10 to the power of 4 plus 2, that is 10 to the power of 6, and unit of electric field is Newton per Coulomb. So this is the net electric field. Easy, this is the part A answer. This is part A answer. Clear? No rocket science here. So if you simplify them step by step, in case suppose you are very confused about 10 to the power, take your time, solve it. You will get a lot of time to solve numerical questions. If you are finishing your theory questions quickly, then you will get at least 1 hour time to solve the numerical questions. At least 1 hour to 40-45 minutes you will get, right. So take your time, solve it, don't make small mistakes. Small mistakes are main culprit, because if you make any mistake in the part A, you will make your part B will be completely wrong. Okay, so what is the part B question? If a negative test charge of magnitude 2 nanocoulomb is placed at this point O, what is the force experienced by the test charge? So force experienced by the test charge is basically given by the electric field times the charge. So Q into E net. Okay, Q into E net. So what is the value of Q? Q is 2 nanocoulomb. Nano means 10 to the power of minus 9. And net electric field we have already calculated, 9 into 10 to the power of 6. So 2 into 9 is 18. So 18 into 10 to the power of minus 3. So this is the force and its unit is Newton. Force unit is Newton. So this is the part B answer. So part B is very simple. If you make mistake while calculating E net, then your test will be completely wrong, force will be completely wrong, so your marks will be deducted. Now let's take the answer once. So answer is 9 into 10 to the power of 6 Newton per Coulomb and 18 into 10 to the power of minus 3 Newton. So both answers matches. Now let's move on to the next question. 2-point charges. Now here we have both of the charges are positive. Again, the diagram is compulsory, not compulsory for the marks, but it is compulsory to understand the question. That's what important. So 2-point charges plus 2 nanocoulomb and plus 6 nanocoulomb are placed at a point A and B respectively, separated by a distance of 0.2 meter in air. So that means the distance already given in meter, so you don't need to convert them. So here we have two charges, points are given A and B. One is plus 2 nanocoulomb. As you can see, the diagrams are not super complicated, they are easy. Okay, the distance between them is given as 0.2 meter. Okay, now find the magnitude of the resultant electric field at the midpoint O. Now again the same question, here we are trying to find the magnitude of electric field at the midpoint O of the line joining A and B. What will be the magnitude of resultant electric field at O if plus 4 nanocoulomb is added to plus 2 nanocoulomb charge? Okay. So that is very, very important to understand. Part B we will solve later. First we will calculate the electric field, and as we have done, first we will calculate the electric field due to the charge at A. So electric field due to charge at A is basically in this direction, positive charge. That means it is away from. So this is what we are saying, EA. Okay. Now what will be the electric field due to B? Electric field due to B will be, again this is a positive charge, so electric field due to B at O will be away from this source charge. So it will be away from. Now I am drawing a bigger arrow. Why I am drawing a bigger arrow? because this plus 6 charge is bigger than plus 2 nanocoulomb. So, that is why we are drawing a bigger arrow. Okay. So, this is how you differentiate and understand. Now, both the electric fields are in the opposite direction. So, the net electric field in this case, what will be the net electric field? Very easy to understand now. So, the net electric field will be EB minus EA. Why EB minus EA? Because the charge at B is bigger and charge at A is smaller. So, it will be EB minus EA. Okay. So, this electric field will be bigger, this electric field will be smaller, that is why EB minus EA. Now, let us put the individual values. Now, here we do not need to consider, both magnitudes are not same here. Be careful, magnitudes are not same because charges are different. So, what is EB? KQ1 by distance is same. Now, total distance is 0.2 meter. Okay. So, this distance will be 0.1 meter and this one will also be 0.1 meter, right, no doubt about that. So, R square minus KQ2 by R square. R is same. Why I am writing it like that? Because I do not want to complicate things, I want to simplify it. So, I can take K by R square as common and in the bracket Q1 minus Q2. Okay, that is why I have taken it like this. Now, value of K we know that 9 into 10 to the power of 9 divided by R square, also given 0.1 whole square, into Q1 is 6 nanocoulomb minus 2 nanocoulomb, and because it is a nanocoulomb, so where student makes mistake, they forget to put this 10 to the power of minus 9. Okay, because it is a nanocoulomb, you have to convert it into coulomb. That is very, very important step. Because I have taken common, because both charges are nanocoulomb, so I have written it smartly 6 minus 2 into 10 to the power of minus 9. Both of them 10 to the power of minus 9, so 10 to the power of minus 9 will be common, and that is why I have written it like that. Now, 10 to the power of 9, 10 to the power of minus 9 will cancel because all of them are in the multiplication form. So, they will cancel. Now, let us simplify this. So, 9 into 10 to 4 divided by 0.01. Okay. So, it will be 9 4s are 36 and 0.01 will go up and it will become 100. So, 3600 Newton per coulomb is the resultant electric field at point O. Right? Clear? Any doubt? If you have any doubt, mention in the comment section below. Now, what will be the magnitude of resultant electric field at O if plus 4 nanocoulomb is added to plus 2 nanocoulomb? So, if you add, so what was our plus 2? Plus 2 was Q2. Okay, so Q2 charge initially was 2 nanocoulomb. Now, you have added another 4 nanocoulomb. So, the total charge is now 6 nanocoulomb. Okay. So, Q1 is 6 nanocoulomb, Q2 is also 6 nanocoulomb. So, in that case what happens? Q1 minus Q2, what will be the value? 6 minus 6, that is equals to 0. So, because Q1 minus Q2 becomes 0, so the net electric field now will be 0. Okay, so, the net electric field will be 0 because both charges are equal now. So, if equal and same charges are present, then the resultant electric field at the midpoint of the line joining them will be 0. So, the first case it will be 3600 Newton per coulomb, in the second case it will be 0 Newton per coulomb. The unit is not required, but if you want you can put that as well. Okay. So, first case 3600, second case 0. Next question, two positive charges of 0.2 microcoulomb and 0.8 microcoulomb, both are positive, are placed at a distance 0.15 meter apart. At what point on the line joining them the electric field is 0? Now, this I am solving it is the most common method. If you remember, there is a formula. If you want to solve it in competitive exam, you have to save time and you can use formula to solve it, but here we will use the basic fundamentals. So, here we have two charges 0.2 and 0.8. So, one charge is 0.2, another charge is 0.8. Now, both charges are positive and microcoulomb. It is not nanocoulomb. By the way, previous problem was nanocoulomb. This problem is microcoulomb. I have seen students, they get confused and put something what they have practiced rather than whatever given in the question. Okay, so 0.2 microcoulomb, 0.8 microcoulomb are given. Now they asked you the point where the electric field is 0, line joining the charges. Okay, so two positive charges, this is called a null point where electric field is 0. Now null point happens where for two positive charges it happens in the line joining the charges. If it is negative and positive, it will happen outside the line joining charges based on the magnitude of the charges. Now here one charge is smaller, another charge is bigger. So the null point, remember that null point will always have closer to the smallest charge. Null point will always be closer to the smallest charge. So suppose this distance is x. Okay, smallest distance from the smallest charge is x. Then what is this distance? So total distance in this case is given as 0.15 meter. So this distance is x. That means this one will be 0.15 minus x, right. So this is the distance between the bigger charge and the null point. Okay, so suppose this is our null point, I am saying this is a 0 or O. Okay. Now what is basically happening at null point? Let us understand that. So in this case what happening is that the electric field due to this charge is away, and electric field due to the other charge is again away. Both charges are positive and both electric fields are magnitude wise same but direction wise different. Okay, in this case both electric fields are magnitude wise same but direction wise different, so that the net electric field EA minus EB becomes 0. So EA is equals to EB. So suppose this is point A and this is point B, this is point A, this is point B. So electric field basically due to A is equals to electric field due to B. Okay, magnitude wise, direction is different but magnitude wise they are same. So if you wish, you can add a magnitude sign over here. That's it. Now what is electric field formula? Electric field formula we already have solved so many problems. It is basically QA by, for A it is x square, okay, for B KQB by 0.15 minus x whole square. Remember there is a square over here. Okay, this is also one point of checking that students make mistakes, that they forget to put the square or do the square in the actuality. That is why the student make mistakes. So K cancels both side, right. It's the equation, so you can cancel same terms. So 9 into 10 to the power of 9, you don't need to write it, it will be cancelled. Now let's put the value of QA. What is QA? QA is 0.2 microcoulomb. Micro means 10 to the power of minus 6 x square equals to, what is QB? QB is 0.8 into 10 to the power of minus 6 microcoulomb. Obviously microcoulomb means 10 to the power of minus 6. So 0.15 minus x whole square. Okay. Now we will do some trick. What trick we will use? We will take only this part on our left hand side and we will take this numerical value on the right hand side. So everything related to x on our left hand side and everything which is constant we will take on our right hand side. Here basic mathematical knowledge is required, because it is in the denominator numerator, it will come to the denominator. It was in the denominator, it will come back to the numerator, right. So it will be 4. 0.8 by 0.2, point cancels. So you get 2 4s are 8. Now what? Now again a small trick. 0.15 minus x whole square divided by x whole square. So I can write them as a square by b square. So we can write a by b whole square, right, equals to 4. Right. Now what we will do? We will take the square root on both sides and we will avoid the negative sign. Okay, because x represents distance, distance cannot be negative. So that means we will take the positive value only. So 4 square root is 2. Okay, 4 square root is 2. Taking square root of both side, right. So, now it is only about simplification. So, 0.15 minus x equals to 2 into x, or 0.15 equals to 2x plus x, or 3x equals to 0.15, or x equals to 0.15 by 3. Now, this is also a point where students make mistakes. They simply blindly write 0.5. Because we have 2 decimals, so your answer after cancelling will also have 2 decimals. So, it will be 0.05, not 0.5. Okay. So, this will be 0.05 meter. Okay. And the distance is measured from the smaller charge. So, you can mention that 0.05 meter from 0.2 microcoulomb charge. This is very, very important as well. Okay. So, the distance you have measured, because there are 2 charges, this distance can be measured from A as well as B. So, you have to mention from where you are taking this distance. So, in this case we have taken it from the smaller charge. So, you have to mention that. So, the answer is 0.05 from the 0.2 microcoulomb charge. Now, next question, a conducting sphere of radius 10 centimeter has an unknown charge if the electric field 20 centimeter from the center of the sphere is 1.5 into 10 to the power of 3 nanocoulomb Newton per coulomb, sorry, and points radially outward, what is the net radially inward, what is the net charge on the sphere? So, basically here we have a sphere of radius say 10 centimeter, and we are trying to find the electric field at a distance 20 centimeter, and it says that electric field is radially inward. Okay, radially inward means, first of all, suppose the charge on this sphere is given by small q, then this charge must be negative charge. Electric field radially inward towards the charge means it is a negative charge. Okay. So, what we have to do, you have to, while calculating the after solving the question, you can put the, because the electric field is radially inward, this is a negative charge, put the minus value, or you can do what I am doing here. So, electric field at this point is given. Now, this is a spherical, you can consider this case to be a spherical shell case, where for any point outside the shell you can consider entire charge is located at the center. For inside points it becomes 0, for any points outside you can consider entire charge is located at the center. So, electric field at the center is given by, electric field at the point of observation, that is electric field, say this point, say P, this is a point P. So, electric field at point P is given by K Q by R square. Okay, R is this distance 20 centimeter. Okay. Now, this electric field value is given 1.5 into 10 to the power of minus 3. Okay. So, and we are trying to find the charge Q. So, Q is equals to EP into R square divided by K. Okay. So, from this equation we have simplified and calculated the value of Q. Now, what I am going to do, because the electric field is inward, while putting the value of EP, I will put minus 1.5 into 10 to the power of 3. Why minus? Because electric field is inward. If it is outward, electric field would have been positive. Now, R square is 20 centimeter. So, 20 into 10 to the power of minus 2 whole square divided by K is 9 into 10 to the power of 9. Okay. So, now calculate the charge. It will be a smaller value definitely, because charge is generally small. So, 1.5 into 10 to the power of 3 into 20 into 20 is 400 into 10 to the power of minus 4 divided by 9. Okay. So, 9 into 1.5. So, 6 into 1.5 is 9. Okay. 6 1 is 6, 0.5 is 3. So, it will be 6. and then 3 200. Okay, 3 2s are 6, 2 2s are 4, so 200. Now, we also have a 10 to the power of 9 over here, this one. So, do not make mistakes, be careful, check, double check. If you feel any mistakes you are making, obviously you have to double check. Now, 2 by 3, I have taken this 100 out. So, it will be 10 to the power of let us see 3 plus 2, this 2 is coming from these two zeros, minus 4 and minus 9. Okay, this 9 goes up, becomes minus. So, the Q value is given by 2 by 3 into 10 to the power of 5 minus 4 plus 1 minus 8. So, it will be minus 0.667 into 10 to the power of minus 8 coulomb, or minus 6.67 into 10 to the power of minus 9 coulomb, or minus 6.67 nanocoulomb. Okay. So, this you can leave your answer here. If you can leave your answer over here, you will get full marks. If you have some time, you can do up to this stage, okay, to look it better. So, 6.67 nanocoulomb is the answer. Now, electric potential capacitance. Now, the next chapter, time for solving the next chapter questions. Calculate the potential at a point P due to a charge of 400 nanocoulomb located 9 centimeter away. So, first we have to calculate the electric potential due to a point charge at a distance 9 centimeter. So, the charge is given here as 400 nanocoulomb. Okay. So, we are trying to find electric potential. Now, it is time for electric potential. Do not be confused, as I always say. If you follow this lecture, definitely it will help you to minimize your mistakes that you are doing again and again, right. So, potential due to a point P is given by KQ by R. So, it is not square, it is simply KQ by R. So, put the value K is 9 into 10 to the power of 9, Q is 400 nanocoulomb, that is 10 to the power of minus 9, and the distance is 9 centimeter. So, 9 into 10 to the power of minus 2, no square over here. So, 9 cancels, this cancels, and you get 400 into 10 to the power of plus 2, this goes up and becomes plus, and it will be 4 into 10 to the power of 4, unit of potential is volt. So, this is the potential, right. Now, next part B, obtain the work done in moving the charge of 2 nanocoulomb from infinity to the point P. Does the answer depend on the path along which the charge is taken? So, the work done is given by, the work done to bring a charge from infinity to the point is basically given by Q into the potential of that point. Okay. Q into potential of that point, Q is 2 nanocoulomb. So, 2 into 10 to the power of minus 9 into 4 into 10 to the power of 4. So, it will be 8 into 10 to the power of minus 5, and the work done unit is joules. Okay. So, this is the work done to bring the charge from infinity to the point P. Okay. So, easy question, nothing, no rocket science, simple. If you get a question from numerical from this chapter, you should consider yourself lucky, because the questions numericals from this chapter are relatively easy. Okay. So, now does it depend along the path? It does not depend on the path, it is independent of path, as electric field is a conservative field. Gravitation, electric field, they are conservative field. So, in that case it is independent of the path. Okay, so the answer is 4 into 10 to the power of 4 volt, 8 into 10 to the power of minus 5 joules, and it is independent of the path. Now, next, capacitance of a parallel plate air capacitor is 1 nanofarad and the plates are separated by 2 millimeter. Find the area of the each plate of the capacitor. So, for that we have to solve C equals to epsilon naught A by D. This is the formula for capacitance of a air capacitor, right. Now, C is given 1 nanofarad. So, 1 nano means 10 to the power of minus 9. Epsilon naught value 8 into 8.85 into 10 to the power of minus 12, okay. And area is given here as area we are trying to find, okay. This area of the each capacitor we are trying to find each plate. So, and the distance is given by 2 millimeter. Millimeter means 10 to the power of minus 3. Millimeter means 10 to the power of minus 3. So, what is the area? So, area is basically 1 into 10 to the power of minus 9 into 2 into 10 to the power of minus 3 divided by 8.85 into 10 to the power of minus 12. So, minus 9 minus 3 is minus 12. So, it will be 2 divided by 8.85, okay, and approximately it will be, I think, 1 by 4 0.25 meter square. 0.2 actually not 0.25, it will be 0.2. Approximately 0.2 meter square is the answer, 0.226. Okay. So, if you use a small calculator, you can calculate the exact value, 0.226 meter square. Okay. So, this is how you calculate the area of the capacitor plates. This is not a 5-mark question. If it is coming, it will come as a 3-mark numerical question. Next, two charges of 10 microcoulomb and 5 microcoulomb are 12 centimeter apart. Find the work done in bringing the charges 2 centimeter closer. This is a very common type of question which comes across midterm across all districts. So, here we have two charges, okay, 5 microcoulomb and 10 microcoulomb, and separated by 12 centimeter. Now, if you what you are doing, find the work done to bring the charges 2 centimeter closer. So, basically you fix one charge, you bring one charge 2 centimeter closer. Any one of the charge if you fix, that will be sufficient. So, if you fix one charge, bring the other charge by 2 centimeter, or fix this charge, brought the other charge by 2 centimeter, that is fine, or you bring both charges by 1 centimeter, that is also fine. It is independent of the path. So, once you bring them to 2 centimeter closer by 2 centimeter, so that means the final distance is 12 minus 2, that is 10 centimeter. So, final distance is 10 centimeter, which is very important to understand. Otherwise, the problem is simple. Okay, now, what is the initial potential energy of the system? Initial potential energy of the system, and what is the final potential energy of the system? So, potential energy between two charges is given by K Q1 Q2 by R square. Okay. What is the final case? So, this is say R1. Final case K Q1 Q2 by R2 square. Okay. So, both Q1 Q2 will remain same, only the distance initially was 12, finally is 10 centimeter. So, what is the difference in potential energy? Difference in potential energy must be the work done. So, if you remember first PU chapter work energy, so whatever is the difference in potential energy, that much work you have to do, right. So, delta U is equal to W, that is you have to put them as K Q1 Q2 by R2 square. It is basically UF. So, delta U equals to final potential minus initial potential. Okay, final potential minus initial potential, that is the work done. So, final minus initial. And one more thing, there is no square over here, potential energy, right. So, potential energy means no square, R1 by R2. Okay. So, K, Q1, Q2 are common. So, you get 1 by R2 minus 1 by R1. So, that is, I am doing the mathematics as much as possible. So, that final stage, only thing that you have to do, you have to put the values R1, R2, R1 minus R2. So, in the final stage, we will only put the values and calculate the answer. So, the work done is basically given by, put the values now. K is 9 into 10 to the power of 9. Q1 is 5 microcoulomb, so 5 into 10 to the power of minus 6. Q2 is 10 microcoulomb, 10 into 10 to the power of minus 6. And then we have R1 minus R2, R1 is 12, R2 is 10 divided by 12 into 10. Okay, R1, R2. Now simplify. Okay, so just the steps. 3 is a 9, 3 4 is a 12, and then 3 into 10 to the power of 9 minus 6 minus 6, 10 to the power of minus 12, 10 to the power of minus 3 into 5 into 10 into 2 divided by 40. 40 means 4 into 10. So, this 0, this 10 cancels, 5 2s are 10, 5 2s are 10 means it will be 3 by 4 into 10 to the power of minus 2. Okay. 5 2s are 10, 10 into 10 to the power of minus 3 means 10 to the power of minus 2. Now, 3 by 4 is basically 0.75 into 10 to the power of minus 2, and because it is a work done, the unit will be in joules. Okay. So, it will be 0, or you can put it at 0.075 into as joules. Okay. Now, next question. This is a again 3 marker or 2 marker numerical question. Following the diagram, value of each capacitor is equal to 3 microfarad. Find the equivalent capacitance across AB. So, here we are trying to find the equivalent capacitance across A and B. We have 3 capacitors in series. So, if we start from here, if you see that these 3 capacitors are connected in series, okay, and this one is connected in parallel to this combination. So, first we will find the equivalent capacitance of these 3 resistors, capacitors C1, C2, C3, and say this is C4. Each of them have same magnitude. So, 3 capacitors connected in series. So, what is the equivalent capacitance? Equivalent capacitance will be 1 by C plus 1 by C plus 1 by C, that is 3 by C. So, it will be C equivalent will be equals to 3 by C by 3. Okay. Again, one more mistakes that students make, they forget to take the inverse here. Okay. This is a step where you have to take the inverse. Okay. C value is given as 3 microfarad. So, 3 by 3 which is equals to 1 microfarad. This is the first equivalent capacitance. So, I am mentioning CEQ1. This is CEQ1. This portion is CEQ1. Now, this one and this one are in parallel. So, in parallel combination, the net C equivalent is basically C plus C equivalent 1. Okay, parallel combination, they gets added, right. So, 3 plus 1 which is equals to 4 microfarad. Okay, as I said, this is not a 5 mark question, this can be a 2 mark or 3 mark question. Now, next, the number density of free electrons in copper is estimated to be 2 into 10 to the power of 28 per meter cube. This is a current electricity question. a copper wire of length 3 meter and area of cross section 2 millimeter square is carrying a current of 6.4 ampere. Calculate the drift velocity of electrons. How long does an electron take to drift from one end of the wire to the other end? This is the part B. So, how to do that? For that, obviously, we will use the formula I equals to NEA VD. Don't be confused by reading the question. It might seem little long, but if you just know this formula, from this formula you can easily calculate the drift velocity. Okay. Only problem is there are few more other formulas. If the question comes from based on those other formulas, then you have to remember those formulas, otherwise straightforward question. Now, current if you see is given 6.4 ampere. So, 6.4 ampere divided by N. N is this number density of electron is small n, which is given 2 into 10 to the power of 28. Okay. And charge on an electron we know 1.6 into 10 to the power of minus 19, and area. Okay. Area of cross section is given 0.2 millimeter square. So, 2.0 millimeter square. So, millimeter square means 10 to the power of minus 6 meter square. Okay, do not need to square the 2 only, you have to put 1 millimeter is 10 to the power of minus 3. So, millimeter square will be 10 to the power of minus 6. Okay. Now, you have to just simplify this. Okay. Okay. So, this is the simple as that. Now, let us see. So, 2 2s are 4, 4 into 16 is 6.4, right. So, 6.4 over here, 6.4 over here, and then 10 to the power of 28. Then we have minus 19 and we have minus 6. So, it will be 25 10 to the power of 3. Okay. So, it is 10 to the power of 3. So, 6.4 gets cancelled and you get drift velocity as 10 to the power of minus 3 meter per second. It is a drift velocity. So, its unit will be meter per second, as you have done in your motion in a straight line chapter. Similar to that, it will be 10 to the power of minus 3 meter per second. This is the first part. How long does an electron take to drift from one end of the wire to other? So, we have a wire. What is the length of the wire? Length of the wire is given as 3 meters. So, 3 meters what is the length? So, the electron which is moving with the drift velocity of 10 to the power of minus 3, how long it will take? So, time is basically given by the distance divided by the speed. Motion in a straight line again. So, x is given as 3 meters and drift velocity as 10 to the power of minus 3. So, it will be 3 into 10 to the power of 3 seconds. Okay. So, this much time we will take to reach from one end to other. So, 10 to the power of minus 3 meter per second, 3 into 10 to the power of 3 second. This is how you solve it. You should know the formula. This is a simple calculation, nothing much, no rocket science. 3 resistors 2 ohm, 3 ohm, 6 ohm are combined in parallel. What is the total resistance of the combination? If this combination is connected to a battery of EMF 2 volt and negligible internal resistance, determine the current through each resistor and total current drawn from the battery. Here we have 3 resistors, 2 ohm, 3 ohm and 6 ohm, they are all connected in parallel. Okay. Let us connect it to the battery as well. So, what are all the things we have to calculate? 2, 3 and 6. So, first we have to calculate the total resistance of the combination. Total resistance of the combination, easy, 3 resistance in parallel. So, 1 by Req equals to 1 by 2 plus 1 by 3 plus 1 by 6. So, that is the value will be 6 common LCM. So, 3 2s are 6 plus 3 2s are 6 plus 6 1s are 6. So, it will be 3 plus 2 5, 5 plus 1 is 6. So, 6 by 6 equals to 1 ohm, not 1 sorry, So, you have to take the reciprocal. So, 1 by 1 is also 1. So, here it will have to 1 ohm. Okay, here is no ohm. Now, so this is the total resistance done. Next is this combination is connected to an EMF of 2 volts. So, the battery EMF is 2 volt. Determine the current through negligible internal resistance. So, internal resistance you do not need to consider. Determine the current through each resistor. So, what is the current through each of them? Say this is I1, I2, I3. Now, if you remember the concept, when the resistors are connected in parallel, what happens is that current through each of whatever is the current, but the voltage across each of the resistor is same as the source voltage. Okay. So, what is the current I1? I1 will be the voltage that you have applied divided by the individual resistance, which is equals to 1 ampere. What is current I2? Again same, the voltage divided by individual resistance. So, 2 by 3 ampere. And what is I3? I3 is voltage divided by individual resistance, which is equals to 1/3 ampere. Okay. What is the net current? Total current? Total current is, you can find it in 2 ways. One is like this. So, it will be 1 plus 2/3 plus 1/3, that is equals to 2 ampere. Or another way to find the current is the voltage that you have applied divided by the equivalent resistance. So, voltage you have applied 2, equivalent resistance is 1. So, this is also 2 ampere. So, both way you can calculate the total current. So, remember the steps. First you calculate the equivalent resistance. For parallel combination, voltage across each resistance remains same. So, that is why you can directly calculate the currents. Now, so this is the answer. Next, a wire of length 2 meter, diameter 0.2 millimeter and resistivity 1.57 into 10 to the power of minus 8 ohm meter is connected in series with a battery of EMF 3 volt and internal resistance 1 ohm. Calculate the resistance of the wire and the current in the circuit. So, first of all we have to find the resistance of the wire. So, how to find the resistance? To calculate resistance, we know that it is rho L by A. If you see, everything is given over here. So, resistivity is given as 1.57 into 10 to the power of minus 8. Length of the wire is given 2 meter. So, no need to convert. And the diameter is given 0.2 millimeter. Diameter means this. So, this is a wire, right? This is the diameter. So, if this is the diameter, what is the radius? Radius is half of that. So, radius is given by 0.2 divided by 2, that is 0.1 millimeter. So, what is the area? So, area for a circle is given by pi r square, right. So, pi r square, you have to put that value. Pi value, pi into r square means 0.1 into 10 to the power of minus 3 whole square. It is a millimeter, right? It is in millimeter. Millimeter to meter is 10 to the power of minus 3. Okay. So, these are the small techniques. If you start using, you will be much benefited in your question solving. So, pi is 3.14 into 10 to the power of 0.1 into 3, 0.1 into 10 to the power of minus 3 whole square. So, that is basically 0.1 and 10 to the power of minus 3, you can write 10 to the power of minus 4 whole square or 10 to the power of minus 8. Okay. So, into 10 to the power of minus 8. Okay. So, this is how you can convert. So, now 10 to the power of minus 8, 10 to the power of minus 8, everything gets cancelled. So, we get 1.57 into 2. 1.57 into 2 means 3.14 divided by 3.14. So, they get cancelled and you get this value as, you get this value as 1 ohm. So, the resistance of the wire is 1 ohm. Next is calculate the and the current in the circuit. Now, this resistor is connected with a battery of internal EMF 1 ohm. This is 1 ohm, this is also 1 ohm, and the battery voltage is 3 volt. So, what is the current in the circuit? Simple, Ohm's law. So, current in the circuit is given by the voltage you applied divided by the total resistance. These two resistances are connected in series. So, 1 plus 1, that is 3 by 2, which is 1.5 volt. So, 1.5 volt is the resistance current. Okay. So, 1 ohm and 1.5 ampere. Next, a series LCR circuit contains a pure inductor of inductance 5 Henry, a capacitor of capacitance 20 microfarad, and resistor of resistance 40 ohms. This is alternating current. Now, we have moved into alternating current. As I mentioned, I will not be solving the questions from circuit theory related questions. I will be doing that in later part when your midterm exam is over. In a detailed video, I will be solving all the circuit related questions as well, and if you want them, please mention in the comment section, sir, I want circuit theory related questions. A series LCR circuit contains a pure inductor of inductance 5 Henry, a capacitor of capacitance 20 microfarad, and resistor of resistance 40 ohm. The AC source is of 200 volt, 50 hertz. It is present in the circuit. Find the impedance, also find the resonance frequency of the circuit. So, first we have to find the impedance. What is the formula for impedance? Impedance formula is given by square root of R square plus XL minus XC whole square. Now, what is XL? XL is called the inductive reactance, and it is given by 2 pi F into L. As I mentioned, simple formula. If you remember the formulas and apply them into mathematical calculations, you can simplify this. So, what is 2 pi F? So, 2 pi is constant, obviously 2 into pi. The value of F is given here as 50 hertz. 50 hertz means simply 50, and the inductance is given as 5 Henry. So, 5 Henry. So, it will be 2 into 50 is 100, 100 into 5 is 500. So, 500 pi. So, it will be approximately 1550 ohm. Okay. So, this is XL. Now, what will be XC? XC will be, XC value will be 1 by 2 pi. The only thing that you need to be careful is to calculate the value of XC. This is little tricky. XL part you can calculate easily. You can use the calculator to calculate the value, exact value. So, XC is 1 by 2 pi F. Always remember, most cases it will be 100 pi. If it is given as 50 hertz, that the current that we use in our domestic circuits, so it will be 100 pi, right? 2 into pi into 50. So, that will always be 100 pi, and then capacitance. Capacitance value is given here as 20 microfarad. Micro means 10 to the power of minus 6. Why I said this is little bit tricky? Because this 10 to the power of minus 6 you have to take in the numerator. Okay, this will go up and become positive. 20 into 100 pi, it will be 2000 pi. So, 3 zeros over here, 6 zeros in the above. So, it will be 10 to the power of 3 divided by 2 pi. So, it will be 1000 divided by 6.28. So, 500 by 3, so that will be about 140 ohm. Exactly value I am not calculating, you can calculate that using a calculator. Okay, now you have to put these values in this equation and calculate Z. So, Z will be equals to 40 square. Remember, it is square over here. XL is about 1550 plus minus 150, 140 square. It will be somewhere around 1440. Okay, exact value I will tell you after I am solving the question. So, this is the approximate value. Okay, I will correct it, no worries. Now, next part is to calculate the resonant frequency. So, resonant frequency, how to calculate that? The resonant frequency, there is a simple formula which is 1 by 2 pi square root of L into C. Directly use the formula, no need to drag it, no need to prove this formula, you simply prove this formula and calculate. So, 2 pi is 2 into 3.14 and square root of 5 Henry into capacitance is 20 into 10 to the power of minus 6. Now, 5 into 20 is 100, 100 into 10 to the power of minus 6 is 10 to the power of minus 4. 10 to the power of minus 4 square root is 10 to the power of minus 2. So, it will be 1 divided by 6.28 into 10 to the power of minus 2, that is 100 divided by 6.28, and you will get the values as 16 hertz. So, this will be 16 hertz and this will be 1412. If you calculate it using proper calculator, you will get this value as 1412 ohm. Okay. Step by step, using a simple calculator, everything is possible to solve. That is why I recommend this chapter. No difficult calculations, no difficult formulas, no difficult concepts. Only thing you have to remember the formulas and apply them properly. Excel and XC calculation is the major hurdle. If you practice few problems on how to calculate XL and XC, then you can definitely solve a question based from this chapter. An AC source of frequency 50 hertz is connected in series with an inductor of 1 Henry and capacitor of 90 microfarad and a resistor of 100 ohm. Does the current leads or lags the voltage? Calculate the phase difference between the current and the voltage. So, how to calculate current or voltage, current leads or voltage leads? So, for that you have to calculate two pillars XL and XC. Okay. Now, we have to check whether XL is greater or XC is greater. If XL is greater than XC, then we say current lags. Okay. And if case number 1, case number 2, if XL is less than XC, then we say current leads. So, if capacitive reactance is more, then current leads. If inductive reactance is more, then current lags. This is the simple concept. Now, we have to check the same thing. So, XL is equals to 2 pi F into L. So, 2 pi into 50 into L is 1 Henry. So, the value of XL is exactly 100 pi, that is 314 ohm. Okay, 314 ohm. Now, what about XC? XC is 1 by 2 pi F into C, which is C is given as microfarad. So, micro means 10 to the power of 6 will go up always. You remember that micro means 10 to the power of 6, nano means 10 to the power of 9. It will be in the denominator because it is coming in the division, it will transfer to the numerator. So, again 100 pi into C is 90. Okay. So, 90. Now, simplify this, you will get this as 2 zeros will be cancelled, you get 10 to the power of 4 divided by 90 pi. Okay. So, 90 pi means XC equals to 1 0 cancel, 10,000 divided by 9 into 1.4, approximately 9 into 3.14, 27, approximately 27. You can consider approximately, approximate, I am not saying exact value, this is an approximation of 30. So, you get this as 33.33 ohm. You put the exact value over here and calculate it, no problem. One of the zeros will cancel. So, you get this as 10 to the power of 3 divided by 9 pi. So, 10 to the power of 3000. I am approximated 9 pi to be 30. which is not accurate calculation. It will be 28, around 28 point something. So, if you do the exact calculation, you will get, I think it will be slightly more than 33, obviously it will be 35, around 35. But major thing that we have understood that XL is greater than XC. So, current definitely lags. So, current definitely lags. Now, how to calculate the phase difference? Phase difference, there is another formula. Phase difference is tan inverse XL minus XC divided by R. Now, some cases you may not be able to find exact value of phi unless you are using tangent table, okay. But even if you are not able to do that, if you leave the answer in the tan inverse form and if your calculations are correct, you will be getting full marks. Minus 35, I am saying this is 35, assuming 35, okay. So, it will be 28 something, this will be 35 something. Divided by R is 40. What is R, by the way? Sorry, not 40, 100 ohm. 40 was the last question. This is 100 ohm. So, put the value 100 and you get this as tan inverse 2.79. I think this is about, what is the value of this angle? About 70 degrees. Okay, if you leave your answer over here, you will get full marks. No worries. If you leave your answer over here, if you don't able to calculate the value using tangent table, leave your answer over here. Simple calculators does not have tan inverse function, so you will not be able to calculate it. But otherwise, if you leave your answer up to this point correct, then you will get full marks. Next, a sinusoidal voltage of RMS value 200 volt and frequency 50 hertz is applied to a series RC circuit in which R equals to 3 ohm, C equals to 800 microfarad. Calculate impedance of the circuit and current through the circuit. Now, in this particular problems, in LCR series circuit problems, diagram is not compulsory, first of all. Okay, diagrams are optional, as you can solve the questions without even drawing the diagrams, as only thing you need is to know the formulas. So, here we have an RC circuit. RC circuit means a resistance and a capacitor. Only these two are connected across an AC source. This is an RC circuit. Okay. So, no L is there. So, what will be the impedance formula? Impedance formula, if you remember, it was R square plus XL minus XC whole square. That is the general formula. Do we have to remember a separate formula? No. No inductor means XL is 0. So, XL is 0 means minus X's whole square. So, minus X's whole square means it will be simply R square plus XC square. Do not just calculate them and add them. So, this is a one mistake that students make. They think that because they are connected in series, so I can simply calculate XC and add them. That is not possible. You have to use this simple formula R square plus XC square. Now, we have to calculate XC as usual. XC is given by 1 by 2 pi f into C. So, frequency is given 50 hertz. So, we will write this 2 pi f as 100 pi and C value is 800 microfarad. So, 10 to the power of 6 will be in the numerator. Okay. You can write one step 10 to the power of minus 6, then you can take this up. I try to avoid one step, that is why I have written it like this. Now, 1, 2, 3, 4, 4 zeros in the denominator, 6 zeros in the numerator. So, it will be only 2 zeros will be left and we will be left with 8 pi. So, it will be 100 divided by 3 8s are 24, it will be approximately 25. You can check that, it will be approximately very close to 4 ohm. So, XC is calculated as 4 ohm, XL is R is given as 3 ohm. So, what is the impedance of the circuit? Impedance of the circuit is simply 3 square plus 4 square, which is very common value, which is equals to 5. Okay, so, the impedance of the circuit is 5 ohm. Next is the current through the circuit. So, this is part A. Part B, current through the circuit. Current is basically given by the applied voltage divided by the impedance. So, applied voltage, maximum value of applied voltage is 200 volt, the Z is 5, so it will be 40 ampere. Okay. Phase difference between current and voltage, phase difference same formula. Now, in this case XL is not there, XL is 0. So, will we be putting minus XC? No, if XL is not present, or in some cases XC can be bigger than XL, we will put XC minus XL. Okay. So, only when XL is bigger, 99% cases XL will be bigger. For 1% cases XL may be 0 or XL is smaller. In that particular case, we will use XC minus XL. In this case, XL is 0. So, minus 0 is obviously same thing. So, that is why XC by R. So, basically XL minus XC is common formula, XL minus XC divided by R, but some cases if XL is 0, then it will be simply XC by R. Same formula, formula is same. Okay. We are not using any different formula. Now, XC is given here as 4 and R we have calculated as 3. Now, this is a very special angle, tan inverse 4 by 3. If you know, you can write it, it will be 53 degrees. If you do not know, you can skip it. Okay. For competitive exam preparation, this angle is a very special angle, 435, right. So, 5 ohm, 40 ampere and 53 degrees are the answers. Now, next is ray optics. These are the last chapter, 3 more questions we are solving. An object is placed at a distance of 40 centimeter from a concave mirror of focal length. So, this is a mirror. I am solving a mirror question. Generally, mirror or lens based question, a simple mirror or simple lens based question do not come, but this question has come in the past. So, that is why I am covering this question. An object is placed at a distance of 40 centimeter from a concave mirror. So, initially it is placed at a distance 40 centimeter for a concave mirror, okay, of focal length 15 centimeter. So, the focal length of the concave mirror, it is given as 15 centimeter. Okay. If the object is displaced through a distance of 20 centimeter towards the mirror. Now, you take this object and displaced it towards the mirror by a distance of 20 centimeter. Okay. By how much the distance of the image is displaced. So, initially this was the object. So, this was the object, means somewhere you will get an image here, okay, and after you move this object closer to the mirror, the image will be shifted. So, what is the shift between the two image positions? That is the basic question. So, first we have to find the first image position. Now, remember that for concave mirror the focal length is negative, U is negative, even V will be negative for real object, real images. Only if the distance is smaller than the F, then V will be positive. Otherwise, for concave mirror, U is negative, F is obviously negative, and V will also come out to be negative. So, 1 by U plus 1 by V1 equals to 1 by F, 1 by U1. Okay, so, this initial distance is U1, this initial image of the position of the image is V1. Okay, these are the things that we are trying to find. We are trying to find V1. So, 1 by V1 equals to 1 by F minus 1 by U1, or 1 by V1 equals to U1F by U1 minus F, okay, or V1 equals to U1F by U1 minus F. Why I am doing it like this? Because if we have derived the formula, we can simply similarly we can say V2 will be U2F by U2 minus F. Once you have derived the formula, same formula can be used for all the image distances. Okay. Now, put the values. U1 is given as 40 centimeter, negative 40. So, minus 40. Focal length is 15, again minus 15. here u1 again minus 40 minus minus 15. So, you have to be careful. So, 40 into 15 divided by minus 40 plus 15. So, it will be 25. So, 40 into 15 by 25. 5 5s are 5, 3, 5 8s are 40. So, it will be 3 8s are 24 centimeter. So, initially it was 24 centimeter away. There is a negative sign obviously because minus 40 plus 15. So, minus 24 centimeter. Now, what will be V2? So, V2 again we will put the same values. U2, now we have shifted the object by 20 centimeter. So, if the object is shifted by 20 centimeter, then what is the new distance? New distance will be 40 minus 20, that is equals to 20 centimeter. This will be the new U2, and obviously negative sign will be there because object distance is always negative. So, minus 20, focal length will remain unchanged. So, minus 15 divided by minus 20 plus 15. Okay. This minus minus becomes plus. So, now let us calculate minus minus plus. So, 20 into 15 divided by minus 5, 3 5s are 15. So, it will be minus 60. So, V2 is minus 60 centimeter. So, what is the displacement of the image? So, displacement of the image, displacement is basically delta V. So, delta V equals to the you can take the magnitude 60 minus 24, that is 36 centimeter. Okay, so 36 centimeter is the displacement of the image. Next, a small bulb, a point source is placed at the bottom of a tank. This is from one of your previous year questions. Also similar question is given in your NCERT textbook as well. A small bulb is placed at the bottom of a tank containing a water of depth 80 centimeter. What is the radius of the circular surface of water through which the light emerges out? Refractive index of water is 1.33. So, here we have a tank of depth given here as, suppose this is water. So, the depth of water is given as 80 centimeter. Okay, you have kept a point source at the bottom of the tank. Okay. Now, what will happen? You have to understand that. So, here we have the point source from where light will go upward direction, right. Now, what is happening here? It is very important to understand that once the light goes here, after certain angle, what happens is that at particular angle, the light will go straight between the plane separating the two media. So, basically beyond this point what happens is that if the light goes after this, it will be totally internally reflected. So, it will happen in both sides, all the sides in fact, and you will observe a circular pattern. Okay. So, this is what happens when you put a light source under the water. Okay. If you have a waterproof lighting, you can check it. Now, we are basically trying to find the radius of this circle. So, basically what we are interested is calculating this distance. Okay, we are interested in calculating this distance. Okay. So, this is the radius of the circle which is formed on the top of the water. So, if you see from the top, you will see a circular ring, and this radius we are trying to find. So, beyond this point, whatever happens is that the light is coming back to the water medium. So, total internal reflection is happening. So, up to this circle, light is able to escape. Beyond this, light is not able to escape. Now, at this circular boundary, it is the angle of critical angle of incidence. So, if you say this will be the angle of critical incidence, so this is theta c. Okay. So, this angle is theta c. Now, if you see that this angle theta c means this angle will also be theta c, alternate angle, right. Z, if you see any z, always remember that this angle is equals to this angle, right. So, this is the basic geometry. So, from there we can say that this angle must be theta c. Now, this is the depth of the water, that is given 80 centimeter. So, this distance we know. Okay. We are trying to find this r, right. We are trying to find this r, and we know this angle theta c. So, we can easily say that from this is the base, this is the what? This is the height. So, we can say that tan theta c equals to r by perpendicular by base. Okay. Some people have curly brown hair turned permanently black. Okay. I explained it in many of the videos. If you have missed, you can go and check that in my basic physics video. I have discussed that. So, tan is perpendicular by base. Okay. Now, this angle theta c, if you consider this angle theta c is very, very small, then this same tan theta c can be considered closer to, now this is an approximation, okay, it will be closer to sin theta c. So, which is equals to r by d. Okay, you can use and calculate, if you calculate sin theta c, from there you can calculate tan theta c using formulas, that is also okay. But for now I am assuming this is very close to theta c's value is small. So, in that case I am assuming this is actually close to sin theta c. Now, in case of critical angle, we know that sin theta c is basically 1 by refractive index, which is equals to r by d. So, the radius is basically d divided by n. Now, what is d? D value is given as 80, n value is given as 1.33. 1.33 can be written as 4 by 3. So, tan theta c is sin theta c by cos theta c. Okay. So, it will be sin theta c divided by square root of 1 minus sin square theta c. You have to do that, no other option. So, sin theta c is 1 by n. So, for critical angle we know that sin theta c equals to 1 by n. So, what is 1 by n? 1 by n is 1.33, n is refractive index. Now, 1.33 can be written as 1.33 is basically 4 by 3. Okay. So, this is a very useful fraction, particularly for this kind of question. So, 4 by 3 or it will be 3 by 4. So, sin theta c is 3 by 4. Now, that value we will use across here. So, 3 by 4 divided by 1 by 1 minus 3 by 4 whole square, 3 by 4 divided by 1 minus 9 by 16. So, it will be 3 by 4 divided by square root of 16 minus 9 by 16. So, that is 3 by 4 divided by square root of 7 divided by 4. So, 4 cancels, 3 by square root of 7. So, this is the value of tan theta c. Now, we will use this over here. Okay. Tan theta c. Tan theta c is what? 3 by root 7. So, 3 by root 7, from here we get r by depth is 80. So, from here we get r equals to 3 into 80 divided by root 7. Okay, and this value will come out close to 91 centimeter. Okay. So, the answer is 91 centimeter. So, this is a small trick. If you can use sin cos table, you can directly calculate it, otherwise you have to use this trick. Two lenses of focal lengths 0.2 meter and 0.3 meter are kept in contact. Find the focal length of the combination, calculate the powers of the two lengths of the combination. This is a very, very popular question in midterm physics paper. This is the last question of the chapter, last question of the session. Two lenses of focal length. Here we have two lenses, focal length f1 equals to 0.2 meter. If you see both the focal lengths are given in meter. Okay, now when two lenses are in contact, two thin lenses are in contact, the equivalent focal length can be calculated as F equivalent equals to 1 by F1 plus 1 by F2, like parallel combination of resistors, okay, or series combination of capacitors. So, F equivalent will be F1 F2 by F1 plus F2. Now, put the values 0.2 into 0.3. So, I have converted into using the knowledge of parallel combination of resistors, I have converted it. Okay. So, do not get confused. So, plus 0.3. So, it will be 0.2 into 0.3 divided by 0.5. So, point cancels, we get 3 to the 6, 0.6, 0.6 divided by 5. So, it will be 0.12. Okay. Now, you can use the calculator to calculate it. I know it, that is why I am putting it. This is easy calculation. Now, so this is the equivalent focal length. Find the focal length of the combination. This is the focal length of the combination. You have to put 0.12 meter. Calculate the powers of two lenses and combination. So, power is given by 1 by F1 when F1 is in meters. Now, here fortunately it is already in meters. So, it will be 1.0.2, that is 10 by 2, that is 5 diopter. Okay. P2 equals to, and it is because it's nothing is mentioned, it will be plus. P2 is 1 by F2, which is 1 by 0.3, 10 by 3. So, it will be plus 3.33 diopter. Okay. So, we have calculated P1 and P2. What is the total power? Total power or equivalent power is basically P1 plus P2, which is 5 plus 3.33, which is equals to 8.33 diopter. Okay. Easy question, nothing, no rocket science, just step by step you need to know this formula, otherwise they are very, very common and simple formula. Now, lens maker formula related questions might come, some complicated questions from ray optics is also possible. These are the simple questions that you, if it is coming from this chapter, you have to answer. Otherwise, obviously I recommend first two chapters and alternating current, ray optics and current electricity should be your backup, not should be your main problem solving part, right. I hope you enjoyed this session. I will be back with more videos very soon. Also, we are planning to make a solution of your question paper, which is tomorrow. So, we will be presenting that as well. So, till then, bye. Thank you for watching.